Okay, project number 4. I'm in my console in my ML working directory. I'm going to type in SML and type in use and my project name. This is project 4.sml double quote semicolon. And in here we've got a data type defined, a prod function, a pin function, a reverse function that also uses the data type mylist. And this just shows the compiled and everything put together. So in this video, I'm going to walk you through a functional programming that's written in standard ML here on the left. The custom type function is the first one over here. Defining our list type, it mimics a built-in list structure. It has two constructors, nil and const. Nil is the empty list, and const, all uppercase, prepends an element to the front of the list. And this is the definition of that list structure data type. This gives us full control over how the list behave, and it lets us build our own utility functions. Making the const infix operator, what that does, infix r5 const, that makes the list construction more readable by declaring the const as a right associative infix operator using the infix r5 const command. This allows us to write lists like 1, 2, 3, 4, nil much cleaner than prefix calls. Function 1 is the prod function. It computes the product of all integers in a list. It uses pattern matching, which is right in here. If the list is empty, it returns 1. That's the first part of the pattern matching. If you actually pass in the list, it multiplies the head with the product of the tail. Function 2 is the pin function shown right here. It takes two mylist values. It returns a new list with the first list followed by the second. It recursively walks through the first list. It rebuilds it with the second list at the end. Finally, I have a reverse function shown here, and it's implemented very efficiently using a helper function inside a let end block. And this keeps the helper private. It uses an accumulator in here to reverse the list in linear time. So as a demonstration, we'll look at a sample run using these features. So the first thing I'm going to do to make it easier to use is use the infix r5 const command. And the infix r is right associative. It makes it easier to write out lists. The 5 is the precedence level. And the first thing we're going to do is we're going to type in, just for saving time, I'm going to paste in value A, my first list, and then I'm going to paste in here my second list. So I've got the A list is 1 through 3, and the B list is 4 through 5. And what we're going to do here is I'm going to define value C to be the product. Or actually, what I'm going to do is I'm going to demonstrate the pin function first. So I'm going to take pinned of A and B. So that should give me B appended on the end of A. So you get 1 through 5. And then value D here is a demonstration of the product function. We'll take the product of C, which we just created. So 1 through 5, if you multiply all those together, you get 120. And finally, val E reverse, we're going to reverse the list C. So list C originally was 1 through 5. Well, reverse should be 5, 4, 3, 2, 1. And finally, val F prod, if I if I pass in a nil empty list, it should return 1, which is one of the cases. So This confirms that each function behaves as expected. It works seamlessly with the custom list type that we've defined, data type. So in summary, project 4, it demonstrates how you can define and manipulate custom types in ML using recursion, pattern matching, infix notation. It's a great example of functional programming. It encourages the clean and aggressive modular code. This concludes project 4 demo. Thank you.